In this video, we are going to take up one more problem on projections of laminas. How to analyze this problem in 3 dimensions and to solve it by using the sketchbook. An equilateral triangular lamina of 25 mm sides lies on one of its sides on HP. The lamina makes 45 degree with HP and one of its medians is inclined at 40 degrees to VP. Draw its projections. So as the lamina is resting on one of its sides on HP, and also he has given the surface of the lamina is inclined at 45 degrees to HP. So since it has to be resting on HP, so obviously we have to start from HP. And also the lamina makes 45 degrees with HP. So obviously that should be 0 degree, that means it should be parallel to HP. Since the lamina has to be parallel to HP, obviously one of the sides has to be perpendicular to VP. Whether the side are resting on HP or a corner is resting on HP, always we have to start the problem from the top view because it is an odd number side. The corner opposite is always a side. So to do that, first we are going to take up the 3-dimensional sketch wherein you have a lamina, as we are told that as I was telling that the surface, since the side is one of its corners, one of its sides are resting on HP, so obviously that side has to be perpendicular to VP. And also he says that the surface inclination is given with respect to HP. So initially the surface is made parallel to HP, that is 0 degrees with HP. Therefore you are getting a line. So what is the position of this equilateral triangular lamina with respect to both HA and VP? The lamina is parallel to HP. Since the lamina is parallel to HP, so we are getting the true length in HP in all the sides. What is the dimension? It is 25 mm. And what happens to the surface of the lamina with respect to VP? The surface of the lamina with respect to VP is perpendicular to VP. Therefore, in VP, you are getting a line. So when you look from the top view, all the sides are visible. So A, B, C, and then, what is this M? M is the perpendicular bisector. So from this corner point, opposite edge, midpoint is the median. So that is mark that as M. How many medians are there? Since you have 3 corners, so we are going to get 3 medians. But which one has to be considered? The one which is parallel to VP. Which is the one which is parallel to VP? CM. Because here also it will be in true length and here also it will be in true length. Now, how to then as you look from the top view, A, B, C and M are visible. So when you look from the front view, A, B is visible, that is A dash, B dash is visible, and C dash and M dash is invisible, so it is put in bracket. How to solve this? By manually or in the sketchbook. First we are going to draw the XY line and you mark VP and HP. And then since it is HP, so we have to start with the problem from the HP. So as we are doing it in the grid sheet, so you measure 25 mm and you mark these 2 points B and C. So then by using the protractor with B as center, taking the radius of 25, you cut an arc, draw an arc towards the left side. Similarly with C as center, cut on the previously drawn arc. So again you will go to get a side of 25 mm. Then since then join, mark them A, B, C. Then join between A to B, B to C and C to A. Then I need to write the front view. So to do that, draw a vertical projector from A and also from B and C to the front view. That is the XY line. So as you look from the front view, A is visible, so A dash is visible. B is visible, so B dash is visible. And then when you look from the front view, C dash becomes invisible. Then you have the point M which is hidden by the point B. So hence AM will not be visible. So put M dash in bracket. So as we know that the perpendicular bisector of this corner with respect to this side BC is parallel to VP, therefore you are getting the true length in VP. So here since all the sides are resting on HP, so obviously in HP all those sides will going to be in true length. So once you do that, now in the second position, he says one of its sides is resting on HP. So that is B dash C dash is resting on HP. So the surface makes an angle of 45 degrees to HP. So you can see here that A, B, C and M all are inclined to what inclination? It is 45 degrees to HP. Okay? Then here, what happens to this point A dash M dash? That A, since the surface becomes inclined, so obviously AM should also become inclined because AM is on the surface of ABC. That is how we can see here. But in this position, you will not be able to see the line. But as you look from the front view, A dash is visible, B dash is visible, and C dash and M dash is invisible. So that is how you are getting a line here. That basically why you are getting that line, because it is the profile itself is perpendicular to VP and inclined to HP. So then he says how to write this on the two-dimensional plane. How to do that? So you take any convenient point, the convenient distance between these two, and mark this point. That point will going to become B dash and C dash in bracket and M dash is in bracket. Then by using the protractor with this point as center, by rotating or by measuring from the clockwise direction of 45 degree and join from B dash to that point and extend it. Then you take the distance from B dash to A dash at the first position front view with B dash as center, cut an arc on that 45 degree line and you mark that point as A dash. Then draw a vertical projector from A dash and draw a horizontal projector from A, you get this point. That A will going to be the point. Similarly, draw a vertical projector from B dash, C dash and M dash. Draw a horizontal projector from B to mark that point B. Similarly, draw a horizontal projector from C till to this line. So you mark that point as C. And then similarly, draw a vertical projector from A dash and draw a horizontal projector from E. Then you are going to get these 2 points mixed here. You mark that point as E. Then draw a vertical projector from B dash and C dash and M dash and draw a horizontal projector from A. Both these two lines will going to intersect at these 2 points and you mark this point as A, you mark this point as M and you mark this point as B and you mark this point as C. Then join A, B, C and A with a dot line. So this is how you will be able to write the second position front view and also to the top view. Then you say one of the perpendicular bisector is inclined to VP at 40 degrees. So that means as the surface becomes inclined to HP, since the perpendicular bisector is on that surface, which is the perpendicular bisector A dash and M dash. What is the length? The length I don't know, but that length will be equal to A dash B dash. So that is the reason why you are taking that length and we are cutting it here, because since AM is parallel to VP, so you are getting the true length. Since this inclination is also the true inclination, so you will going to get the true length directly. So once that AM becomes inclined to HP, what happens here? This will going to become apparent length. But what the problem given? The problem what he has given is the true inclination, which is 40 degrees. But I cannot rewrite this sketch on that 40 degree line. Why? Because the inclination given is the true inclination here. What that true inclination? It is the perpendicular bisector's true inclination, which is 40 degrees. But what you have here is the apparent line, and you are rewriting this sketch here. So obviously you cannot take this directly. So what we do? We take any convenient distance on this point. You will cut an arc on this. What is the length of that line or the arc AM? That is from the first position top view. Then once you get this point, you draw a locus. Then you measure the distance from A to M with same A as center. Cut an arc on this side, on the locus side. Then you join. So you will going to get the beta inclination line. Once you get the beta inclination line and once you know this point, so you take this three-dimensional sketch and place it here. Then automatically what happens, this will going to be get this point here directly. Then you know that B and you know that this is C and you know that this is M. Then you know that this is A because you draw a vertical projector from here to this. So this is the actual final position of your equilateral triangular lamina. When you look from different view, that image is being projected here, A dash, and this B to B dash, and this C to C dash. So then you are going to get the front view of this particular orientation lamina. Similarly, I want to get the top view. So from top view, you draw a vertical projector from C, or it is from A. Then B and C and M is already on HB. So only the point which is A has to rest on HB. So then once you get this, so this is the triangle what you will going to get in the top view. So this is what you will going to get it in the front view. So here, this is how we will be able to analyze the last position of the three-dimensional sketch. So how to write that? So here, as we know that once the surface becomes inclined, then AM is also, that is A dash M dash is also inclined. So you are getting the apparent length. So you take any point and by using the, draw a horizontal line, by using the protractor with A as center, measure an angle of 40 degree first, measure an angle of 40 degree and draw a inclined line with respect to this horizontal line. Then as we know that this is 40 degree is the true inclination line, so we need to get the true length of the perpendicular bisector. Which is the true length of the perpendicular bisector? This is the one which is the true length of the perpendicular bisector. With the same center A, with A center A, and then you measure the length of AM. What is the length of AM? It is true length, because on 40 degree line you are getting the 40 degree is the true inclination line. So with A center, taking the radius of AM of the first position top view, since it is a true inclination and this length is also true length. Why it is in true length? Because this is A dash M dash is the line which is parallel to HP, so you are getting the true length. AM is parallel to BP, so you are getting the true length here. So you can take only the top view length with by measuring from A to M with the same center A, cut an arc on this locus line, cut an arc on this 40 degree line, and then draw a horizontal projector. Then you know as the A dash M dash becomes inclined to HP, so you are getting the apparent length. But as AM is parallel to BP, you are getting the true length here. So by using the compass with A center, taking the radius of AM, you take these two radius. Then with A center, cut on the locus line and you mark this point as M and join A to M. Then with M as center, with respect to MA, you measure an angle of 90 degrees and then draw an inclined line. Similarly with M as center, taking the radius of MP and MC, both are equal. With B as center, cut an arc on this side and also cut an arc on this side. And then you mark those 2 points as B and C. Then I need to write the front view. How to write that? With A as center, draw a horizontal projector from A dash and draw a vertical projector from A. Both these two lines will going to intersect at this point, which is A dash, and draw a vertical projector from B to the XY line and also from C to the XY line, and you mark these 2 points as B dash and C dash. Then join A dash to B dash to C dash to A dash with a dotted line. So then you measure this and you give this angle as the beta inclination line. So this is how you will be able to analyze and write analyze the three-dimensional sketch and then writing it on the two dimension by using the sketchbook. Now how do I know that my problem is right? You can see that one of the sides is resting on HP and one of the perpendicular bisector is inclined to VP at 40 degrees. So naturally I need to know what is the beta inclination, that is the apparent inclination. Why I should find out the apparent inclination? Because of this, wherein you have this apparent length, therefore you need to find the apparent inclination beta, and on that line you need to construct this. So as now B dash C dash is on HP, and one of the perpendicular bisector is inclined to VP at 40 degrees. So obviously I need to know what is the beta inclination, that is the apparent inclination, and one of the sides is resting on HP and the surface is inclined to HP at 45 degrees, and this is the side of polygon of triangle of 25 mm sides, or the equilateral triangle of 25 mm sides. So since we have considered all the data given in the problem to arrive at the solution, and hence my problem is right. So this is how you will be able to analyze and write the solution by using the sketchbook. Thank you.